These are in listen-only mode.
Welcome to the webinar and release of Camo's latest version of the Unscrambler X, version 10.2. My name is Tracy Solfrank, and I'm a Senior Account Manager with Camo. Presenting today, we have Dr. Catherine Bakev, Camo's Chief Scientist for North America. Catherine holds a PhD in Polymer Science and is an expert in spectroscopy and chemometrics, and has a wealth of experience in multivariate analysis. Camo develops multivariate analysis software and solutions suitable for a wide range of data analysis tasks, of which the Unscrambler X is the core of our product family. We also have complementary software which allows the use of the Unscrambler models to be deployed in real-time analysis in a production environment. In addition, Camo has a full range of professional services, including consultancy to assist in building models. We also offer training in multivariate analysis, as well as a complete range of IT solutions and customization. The company was established in 1984 in Norway by a group of scientists who developed the software for clients in the food and beverage, the oil and gas, and the pharma sectors. The first commercial release of the Unscrambler was back in 1986, and in 2010, Camo celebrated our 25th year anniversary of the Unscrambler X suite of products, a completely re-engineered version of the Unscrambler. In 2011, we released version 10.1 of the Unscrambler X, along with Process Pulse for real-time multivariate process monitoring. Today, Camo has over 3,000 organizations with more than 25,000 end users who use our software for product development, manufacturing process control, understanding customer behavior, and overall making better and more accurate forecasts from their data. In fact, the Unscrambler is even used by NASA on Mars on the rover Curiosity for the classification of rock samples. Over the years, Camo has grown into a global organization with our corporate office located in Oslo, Norway. And we also have operational and support offices in New Jersey to service the North American market, and additional support offices in Yokohama, Japan, Sydney, Australia, and our R&D is headquartered in Bangalore, India. This gives Camo genuine global reach and the ability to service our clients wherever they are. And with that, I'm going to turn it over to Dr. Bakev.
Hi everyone, welcome to today's webinar. I will be talking us through what's new in the Unscrambler 10.2 and then demonstrating some of the features, and hopefully if time permits we'll be able to have time for addressing your questions at the end. The Unscrambler 10.2 is a really great advancement for us. We've spent quite a bit of time in this past 15 months working on improving the data handling and performance of the Unscrambler X to allow us to work with big data more effectively. We've improved the reliability, security, and usability of the Unscrambler with this, our latest release. I'd like to summarize some of the updates we've made and then walk through some of the different menus and screens to show you what those are. But indeed, for 10.2, we've optimized the overall performance of the program, mainly based on the way that we're storing memory during our calculation. We've also enhanced the security, now allowing one to install the software in a compliant mode and to put digital signatures on projects, something that is very important to those of our customers who are working in regulated environments. We've also improved features for data import, adding an Interpolate function that will allow one to bring in data that may not have a perfect matching of the beginning and end points of the same size data matrices. as well as adding additional file import functions to be able to read directly file formats from instruments from RapID, Visiotech, and Delta Nu, as well as adding an export function to export models that are compatible for use with the Delta Nu handheld Raman spectrometers and their NuSpec software. We've added additional transformations, including improving our orthogonal signal correction, OSC, which I'll talk about a little bit more. And we've also added additional methods. The most large change has been the addition of support vector machine regression, but we've also added contingency analysis, min, max, and mean plots with descriptive statistics, and graphics for classification done using linear discriminant analysis or support vector machine classification. One can also now recalculate a model with new data, allowing you to add new data or to overwrite data that have been used in one model to update that model. Many of our enhancements are to make your use of the Unscrambler easier, so we've improved our define range dialog, making it more intuitive, and added some icons to make it easier to navigate and customize your plot. So we've added a legend icon and an icon to display points. We've added the feature of converting from nanometers to wave numbers for those working with spectral data. We've added a fill as a right-click option when you want to fill an entire column with category variables. You can also now insert or append copied cells, copy and paste headers and category variables, sort your loadings. We've added the option to discard residuals, which is quite helpful when working with very large data sets because our residual matrices tend to be very large, being 3D matrices of all the residual results related to an analysis. You can add block weighting, and we've also improved our search option within our help menus, and this version of the Unscrambler is the first that's available in the Japanese language. Our Design of Experiments module has been updated greatly with new features including blocking and the ability to include up to 35 design variables for Plackett-Berman designs, and many enhancements in terms of our plots, our handling of data, and our display of our data. And I'll be also demonstrating the new improvements in the DOE module at the end of today's seminar. So now I'd like to talk through the different things that we've changed, beginning with the Imports menu. So under the Imports menu, we've added this option now that when you're importing data from many different formats, you have the ability to interpolate that data. Here we see that we have data which have the same number of points in the data, but the beginning and ending points for the X don't exactly match. And in the previous versions of the Unscrambler, one was not able to bring those data in together into one data matrix because of this slight offset coming about from the instrumentation on which it was collected. So now, if you have the Interpolate option, these data, which all have the same number of X variables, can be imported into the same matrix. You see here when I have Interpolate, they're all chosen as matching spectra now. We've also added additional file import options, and more details on these different types of file formats can be found on the websites of the respective vendors for those, the RapID, the Delta Nu, and the Visiotech file formats. And we've improved our ASCII batch import and in general our import of both Excel and ASCII file formats, where now if you have many ASCII files you'd like to bring in together, you can bring them in together as a batch as long as they have equal dimensions, and you can also transpose the data before you do the import so that it is in the right format to do the analysis, where in each row is a sample and each column a variable. Some of the biggest changes have been in adding additional compliance and data integrity options. So now, as the part of the new installer for the 10.2, you have the option to set the program up in the compliance mode during your installation of the software. This means that Windows authentication is used as the default electronic signature in your audit trails. When working in the compliance mode, the audit trail can't be emptied. It can only be printed or saved as a PDF format. Likewise, the audit trail cannot be turned off, which is something that can currently be done under our Options tab. And the user setup privileges also are disabled when working in the compliance mode. Accordingly, we've also updated all the info boxes and audit trail information to make them a higher level of compliance. So in version 10.1, the info box for a project would have the information of the project name, who's logged it in, and which version it was created in. Now in version 10.2, we have additional information including when a project was last saved and by whom, and indeed if you're working in the compliant or non-compliant mode in working with those data. In the compliant mode, you can then sign projects. Well, actually you can sign projects even in the non-compliant mode, and this is done by going under File Security, Sign, and then you will see at the bottom of a project that the project has been signed and the digital signature is in place. So therefore, this makes it such that if a project is changed in any way, that digital signature would be invalidated, and this is a good way to track that the data have not been changed in any way. If you were to pass along your data to someone else, one thing you could do is indeed lock it with a password protection. You could also sign it such that if anything were changed, it would be noted and the signature would need to be updated. For editing, we've made some vast improvements with our Define Range dialog, which I show here, wherein now you have the ability to see all the row and column ranges that you have defined and make updates and changes to them all at once when you are in this dialog. Likewise, we've moved the special intervals option to a collapsible option on the side of this menu, and here you can then make changes and create row sets and such based on random groupings as well as based on category variables. So we believe that we've made this a lot more intuitive and easier to operate. We've also made some additional enhancements in terms of having the fill option as a right click when you're dealing with rows of category variables. You can also convert your scale of values from wave number to wavelength. We've added the duplicate matrix as a right click when you choose a matrix in your project navigator. Likewise, we've added a legend for or an icon for adding a legend, as well as an icon for adding or removing points from your plots. Changes in the transformation menus include adding the transformation of interpolating, which uses splines to assist in matching data sizes in tables. And this is useful when you're combining data that have been collected perhaps on instrumentation of different resolutions. So you would, as with other transforms, choose the data for which you'd like to apply the transform, and then define the original scale of the data and then the target scale that you would like to use. So in this case, I have spectral data that is at 2 nanometer steps, and then I'd like to interpolate that to be 1 nanometer steps so that I then have twice as many columns in the data as originally. Likewise, we've added the quantile normalization, and you can use different types of normalization here, as well as define a reference vector for this normalization. And this is very ideally suited for microarray analysis, such as used in metabolomics and other omics fields. The OSC transformation we've now updated and changed to now be using Tom Fern's algorithm. So with this in mind, those of you that have applied OSC transforms on previous versions of our software will not have a match then of the result to this transform now, so you'll need to update your models accordingly. With this transform now, we're making use of a PCA algorithm rather than the PLS algorithm for correcting the data and making these transforms. Other changes come under our analysis and prediction, wherein one is indeed the addition of max, min, and mean plots in our descriptive statistics. So when you run descriptive statistics, you now have the ability to also see plots like these where you have the ability to then look at the variability of each of your variables across all samples, where this is then a control chart of my variable brightness, where I have the sample, which is shown here in the top, highlighted with a dot in the control chart. But in the top chart, it's the min, max, and mean for this sample across each one of the variables, and it's displayed here with the min, max, and mean values for that variable across the data set. So though we're doing multivariate data analysis, it's also very important to look at our data to understand the variability in our data on a univariate sense to enable us to be able to interpret and understand our results. We've added support vector machine regression as one of our regression methodologies, and this method then allows one to handle nonlinear systems better than our classical methods of partial least squares, multiple linear regression, and principal component regression. So when you do an SVM regression, as with the others, you define what are your predictors and responses. And in this case now, when you do an SVM regression, you need to choose the settings for what that support vector machine will be, and that's on the Options tab. But then you get, as a graphic, you get a predicted versus reference plot, wherein you can then highlight which are the support vectors that are used in this model. We don't have validation by test set in this, but we do use cross-validation in our SVM R. So it's important to then test your SVM by using prediction, and you can do that by going under Tasks, Predict, SVR Prediction, and you would get the predicted versus reference then with the statistics on the predicted values shown here. As I mentioned, when you use support vector machines, it's important to set the parameters to get the best classification or prediction rates you'd like. It is an iterative process to get those settings. And to help in doing that, we've added a grid search. So if you select the grid search, you can then have the software iterate through to find what are the different settings for the gamma and C values and epsilon indeed for your SVM, and then you can choose a value in the table which gives you the error that you'd like, and then see how well that would perform based on the statistics shown here. So you want to make sure that even though your error is low, that you also have a good root mean square error of your validation and R squared for your validation. If you are pleased with that, you can then click on Use Settings. It will then apply those settings as you do your SVM regression. Another tool that we've added under our statistical test is contingency analysis, and this is a useful statistical method for comparing non-numeric data tables. So we often use categorical data in our analysis, and this enables us then to make those comparisons, get the contingency values, as well as the statistics that go with that. So we can see indeed in this case where we have data on the success of a drug treatment based on gender, that from our contingency table it does look like it is most successful with a positive response for male subjects, and the statistical table with a p-value of 0 does support that fact that this is indeed a significant result. We've made improvements to our current methods such that now the scores plot that you get in your models now by default show both the calibration and cross-validation results for each sample in blue and red respectively. So here we can see that these samples are predicted quite well in the cross-validation. They're nearly overlapping with each other, and this can be toggled on and off. We've also added under both our transformations of weighting and the weightings within your analyses the ability to apply block weighting. So one could choose block weighting and then apply weighting to different blocks differently. Under the Validation tab, you see you now have a checkbox wherein you can discard residuals. Again, the residuals matrices that are created are quite helpful and important to help us analyze and as well as predict new values, but they can get very large and take up over 50% of the size of your models. So when you're working with big data, discarding residuals can make the calculations faster as well as make your model sizes smaller as well. Another addition in our analysis is the ability now to have 1D line loading plots that can have now the correlation loading shown on them. Our correlation loadings are especially useful when we're interpreting which are the important variables for our modeling. And we do have now the 2D loadings plot, which are good when we have smaller data sets, but when we get into instrumental data, it is more helpful visually to see our loadings as a line plot so that they're depicted as our data themselves are, resembling a spectrum or a chromatogram. And then having the correlation loadings as a 1D plot, we then have limit lines, upper and lower, where here the lower line coincides with -1, so it's difficult to see. But from this we can then determine that for this first factor of this model, these wavelengths that are between these limit lines here at the top would be those that are the most important in modeling this relationship between X and Y. We've also added the ability to plot your loadings in ascending or descending order by using arrow bars in the toolbar. Visualization of results is always important, and with that in mind, we've added visualizations for the classification methodologies of linear discriminant analysis and support vector machine classification, where now we have the plots that for LDA are showing the groupings of your different groups that you're doing classification on based on as relative probability. So here we can see that we have a pretty good separation of the groups with an LDA classification, and indeed we have the statistics of those results shown here. And here for an SVM classification, likewise, we're showing the % accuracy for the training set and for cross-validation here, and we see that we have a bit of overlap between these two classes here, but otherwise this SVM classification does appear to have a pretty good separation of the plot of the classes. Another thing that we've added now to our statistics that we show on our predicted versus reference plots in regression is the Pearsons R squared value. We've always shown the R square value, and this indeed is a measure of how much variance is captured by your model, whereas the Pearsons R squared is the square of your correlation value. So we've added now the Pearson R squared to the statistics box just below correlation and above R square. And of course we want to have values for a good model where the Pearson's R squared and R square are close to each other. But of course we need to keep in mind that it's not all about getting a high R squared value. It is about modeling and being able to predict new samples from the models we develop. We've also done further refinements in our terminology for our predicted versus reference plots to be more consistent with the literature. We've always had our R square and correlation values, and we've always listed it as RMSE, leaving that last letter blank. But now we've added those letters so that depending on how you're doing your modeling and your validation, it is clear from the statistics that are described. So if for calibration models, the statistics include the RMSEC, root mean square error of calibration. When you've cross-validated your models, that's given as RMSECV for the cross-validation root mean square error. And when you're using a test set, it is indeed the RMSEP. Whereas if you're using leverage correction and it's just an estimate of the error, we give that as RMSEE. And of course, in general, scatter plots, which you may have in many different points within your analysis, it is the RMSED for the root mean square error of determination. We have made many updates for our design of experiments module, improvements in our calculation, and the ability to add blocking for full factorial designs. So if you have a full factorial design and want to test this with blocking, you then have the choice then of the number of blocks that you'd like to use. And then in your ANOVA table, you will then get your values for your model as well as for that of your blocks. And by looking and analyzing this, you can see whether or not there's a significant difference in performance of blocks and whether or not you need to randomize your designs. So I'd like to now talk about what's coming up in the pipeline in the future for the Unscrambler, but before doing so, I'd like to show you some of the features that I've just described to you. So now I'm going to go over to the Unscrambler 10.2, and the user interface is as it's been now with the Unscrambler X, but we have added features in terms of additional file import formats, and we've made some improvements in some of the imports. So if I were to import, for instance, data from the Opus format, what I can do is, in my existing case, if I have samples that have the same number of data points, but those data do not match exactly on X and Y, if I wanted to auto-select the matching spectra, with this data set, there are only 3 that match with my first one here. If I use the Interpolate function and auto-select, I can see that now all 40 of these sample spectra can be imported together. So that allows me to import those data. I want to include my file name with those, and of course we can preview those data as well as we could before. So I can now import those data all together in one matrix as shown here. And these data are in wave numbers. I could convert those to wavelength by coming under Edit, Convert to nanometers. So now it's showing me that the unit of measure here is nanometers, and I'm going from 781 to 2778 nanometers for these spectral data. We've also made improvements in our import of our ASCII and Excel format. So if I import an ASCII file, what I'd like to import are actually the response variables for this data set I have. So here I now have the ability to have it auto-detect whether my data are numeric or text. I can have it skip lines if I have many headers here. Also, as before, I can define whether or not I have headers in this. And here, of course, I don't have a header in this column here. So just clicking OK, that then brings in this matrix of my percent moisture values that coincide with these spectral data. Likewise, improvements in the Excel import. So File, Excel import. I can come under here and import some data from Excel, and again it can automatically detect whether I have numeric or text data. I can skip rows, and indeed if I had different sheets I could bring in those different sheets. So clicking OK, I've now brought in these data. So I have a text column and many numeric columns. The text column here I'd like to change to a category variable by right-clicking, changing data type to category. And those categories are indeed the values that are in that column. So we've made some changes and improvements as well in our define range menu. So for this data set, which are some economic data, quite old actually, for different countries in Europe, I'd like to create row sets based on the different categories that I have here. So coming to the define range dialog, I can now come to my special intervals and choose my category of region, and if I choose Eastern as my region, it's now automatically highlighted all the rows for which Eastern is the category, and I can now create this row range by clicking Create. I can now choose my next range, Nordic, create this, and go on through all of these to create these. So I now have the 4 different row ranges. Likewise, if I wanted to create column sets, I could create column sets here. And I don't know why it's not letting me do this, but we can do this. And if I wanted to have my West samples as my calibration set and wanted to choose all the others as a test set, for instance, I could choose the inverse selection here and make these my non-West samples. So creating this like so. So that's an update then in our Define Range menu. Likewise, we've made some changes and additions in some shortcuts for our plots and such. So if I were to plot these data here, which are spectral data, I can make a line plot of all these data. And if I wanted to add points to those data, or a legend rather, I could click on the legend key up at the top. I could add points to the data or not by using the show points up at the top as well. We've added many security features, as I mentioned, and my installation here, as you'll see in my info box, is that I am operating in a non-compliant mode, but even in this non-compliant mode, I have the ability then to sign this project. So I can come to File Security, sign a project, and it shows that the project has been signed. It should not be edited. If anyone tampers with it, the signatures will be lost. And that then is an entry in my audit trail. So all the activities that I've done on this project are shown here, and then the last entry is indeed that I've digitally signed this. Other changes that have been made and additions are under the transform menu. We of course have the transforms we've had before, changing the derivative naming to gap, segment, and Savitsky-Golay. But we have indeed added the Interpolate as well as the Quantile normalization. And indeed under weights, you now have the ability to use block weighting. So to show you a little bit about the changes in the analysis, I'd like to come to this data set wherein I have some FTIR spectra with different concentrations of a reagent in them and do a regression for this. So I come under Tasks, Analyze, Partial Least Square Regression. And in this I have a row set of 17 samples, and I'm looking to relate my FTIR spectra versus the percent reagent. We don't apply weights typically with these data, but if I wanted to, I could block weight here as well if I did not want to do that as a transform. And under validation, we of course have the similar settings, prediction diagnostics for cross-validation, our uncertainty test, and here you have the option to toggle on and off the discard residuals. But we'll leave this as it is, and clicking OK, we now get our PLS results. Now I can easily change the name of my PLS model here. It's still active for me to change my name of my model here. Likewise, I could come back later and change it by right-clicking and choosing Rename. But now it's active to allow me to rename it very easily from the raw data, from when I've just created that model. You may note here that now in my scores plot I have red and blue because indeed by default we're always showing the cross-validation results now in the scores plot, and I can toggle that on and off using the cal-val buttons up at my toolbar. Likewise, I can toggle on and off a legend. I can even toggle on and off now showing labels here, so I can have it just show points. Within our predicted versus reference plots, when I have the calibration and cross-validation results both, my statistics are shown thus. If I turn off the validation, you'll see that here I have my RMSEC from my my calibration results. If I look at it for validation, it would show me that these are my RMSE CV values, and of course in both instances I have the R squared, the Pearsons R squared added as well. It can be quite helpful for us to be able to identify which are our important variables for our spectral data by going back to our loadings. Our regression coefficients are shown as a line if we've designated our data as spectral data. But if I want to understand which are the important variables based on for each factor, I would come to PLS loadings, plot this as a line, and now I have in my toolbar the correlation loadings plot. So here I can see that for factor 1, these variables here and here would be important for my model, and for factor 2, these wavelengths here and here. So I could mark those and I could recalculate my model. We've also added now in our prediction some additional values that we compute. So if I use this PLS model now, tasks, predict regression, and I apply this to the other data in my model, in my data set, I can now, in addition to getting my inliers and outliers, which I can plot, so I have my predicted versus deviation values plotted. I have here the predicted and deviation values for the optimal number of PCs, and these two tables are now tied together, so if I change the number of factors here, my values here also change. But we've also added under our outputs the hoteling t-squared contributions for each one of our samples and the Q residuals contributions, which of course you could plot if you were interested in looking more closely into your data and how your data vary relative to your calibration set. We have added support vector machine regression, something that's quite useful for nonlinear data. Here with this spectral data I can do a PLS regression quite successfully, but let me now run the analysis of these data using the SVM regression. So this is under my Analyze menu, and here again I'm choosing the predictors, the samples that I'd like to use, and I have 17 calibration samples of my FTIR spectra versus the percent reagent. And now I come to my Options tab, and we have different SVM types one can choose from, and these are all quite fully explained in our Help menu. And then the different kernel type, the default being the linear kernel type, and here is where we have a grid search. So the default settings for my values are here, but I don't want to have to iteratively go through and try the settings to get my best model. So I'll use the grid search to help me determine which would be the best settings then for my values. So clicking Start, it's run through. Oh, I thought I ran this before. Well, let me go back. I actually must have used a different type of kernel type before. Grid search on this, and it's running through, and I'm seeing that these are then the errors that I'll get with the settings that are designated there. So I could see that if I chose this setting, for instance, I don't get very good values for this type of model. So actually this is a data set wherein actually using the support vector machine wouldn't really give me an advantage to do that. But if I found settings that I found to be quite good, I could apply those and use it and run my SVMR, get my predicted versus reference results as shown here, and to determine or to display which are the support vectors that are used, I can click on support vectors, and here I see that indeed about 6 of my samples are the support vectors that were used in this model. And of course that information is all here as well under the results matrices, and this is actually showing me all which of these 11 they are. The other enhancements that we've made are indeed within our DOE module. To run a DOE within the Unscrambler, you come under the Insert menu, Create Design, and here I can then walk through using the DOE wizard to create a design. So I'll quickly create a design just with 2 different factors, and what I'd like to do is I create the design with my goal, and then I define my variables, and for this I'd like to look at temperature which is a continuous variable between 0 and 80. And catalyst. I'm running a reaction, so I'm looking to see how my yield will change based on whether I use catalyst A or B and temperatures 0 or 80. So my response is my yield. That's my response. So it's set this as a full factorial. Under choose design, I can look at this in beginner or expert mode, and indeed I could split this into blocks if I had more variables. Then under design details, I can see the design points. I can add additional experiments. For this one, I'd like to run replicates but not have center samples. I can randomize or not. And then I get a summary where I can look at the power of my design based on the standard deviation and delta for my response. And I can see here that my power here is sufficient using 8 experiments here. And then I can have my design table and have that in standard order. So clicking finish, what we've done now is in the DOE, we now have that our design variables and our response are all in one matrix. So now I can enter the values for my response, and I have those here in an Excel spreadsheet. So I can copy these and paste them into here. Yep. Paste. Not wanting to paste. So let me just quickly type those. 29, 20, 38, 59, 20, 42, 61. And now I can run my analysis of this simple full factorial design. So to do that, I go under Tasks, Analyze, Analyze Design Matrix. My model imports, indeed, my design variables, but I'd like to look at main effects and interactions. And then my response, this column response variable. Clicking OK, it's now run my analysis. I get my ANOVA table. I get my effects plots for each one of my variables. I can see my interaction effects here, the summary of values, and then I have all sorts of other results that I can look through, including the cube plot showing me the values at the different values for the different levels of the different components. So that's an overview of what I wanted to show you in the Unscrambler today. But I did want to also tell you about what we have in our pipeline. So in our pipeline, one of the key things that we're working on is the ability to develop hierarchical models. In some applications, we actually want to use multiple levels of classification or prediction to resolve ambiguities or to come into a more fine-tuned result based on having values that span a very large space. So hierarchical models allow us to do this, and we are looking in our next release in the coming year to have the features for the following situations of hierarchical models. A classification hierarchy where it's a cascading type system for resolving ambiguities on classification. Classification prediction, something that is quite often used in process analysis where one first wants to identify what a sample is and then apply the correct prediction model based on the correct identification or classification of a sample. And then prediction hierarchical models, wherein you can apply a more refined model after an initial rough first estimate. So just as an illustration, prediction looks like something like this, wherein if you had values that span from 3 different regions, A, B, C, you could have local models across these different regions. So if you had a global model to begin with and your result was predicted in region A, you would then apply the region A model, which is more linear across that region than to use the entire global model. You can also define the tolerances for the junctures of each region here. So this allows you to go from having a global model and trying to have a predictive model that covers a very large area to something that can be more specific over a smaller range of values. So as you know, the Unscrambler 10.2 is now released. You can download it from our website, and those with valid service and support agreements are entitled to this upgrade. You can download it from our website, and there's a lot of information on our website about this, and I actually wanted to walk over and show you the website here. So this is coming to our website page under Home Products, and this is the page for 10.2, where we have the installation guide and release notes accessible here, and you can download it from clicking here. For those of you on maintenance, you can click on the maintenance program. Oops, that wasn't the click. Yes, and from here you can get your free upgrade. Clicking here and typing in your valid email address, then you will get your license key automatically sent to you on downloading the Unscrambler X 10.2. There are more updates on the product page on details about this. Indeed, our help documentation and tutorials have also been updated. And with that, I do believe we have time for some questions. So if you've typed in questions, I'll begin to read those now and see if I can begin to answer those for you. This webinar is being recorded, and we do expect to be able to make it available for download from our website. So come back and visit our website to see that, and as many of you probably know, from our website you can reach our archived webinars. So this one would be part of that. Under free webinars, and then it takes you to a tab for archived webinars. Right here under archived webinars. So you can access many webinars that have been conducted over the past several years actually. Someone asked about importing of different file formats. We are constantly looking to add and enhance these features. If there is a file format that you feel that you need, do please be in touch with us, and we'll work to get the information, if possible, to add that to our offerings of the file imports. So I encourage you all to visit our website and download the Unscrambler 10.2. By all means, be in touch with us directly if you have any questions. Tracy and I are happy to present today, but the rest of our U.S. team are John Chartier and Frank Felice, also at your service. Another question was, do we have a recording for our 10.1 that we released in January of 2011? We do have the release notes available on 10.1. and some information regarding that, but I do not believe that we have a recorded webinar. Someone's asked again about the link for getting to the download. Let me go back to our website to help you find that again. So if I come to, I'll walk you through this. I'll go back to our home page. From our home page, I'll go to our products. Oops, I just clicked the same button again. It's hard to talk and navigate at the same time. So coming to our products page, I go to the Unscrambler X page, and I click on maintenance program. And the maintenance program does show up on some other pages as well. This is the route that I've taken to get it. So clicking on the maintenance program page, which describes what the maintenance program is, which allows you to get support and help and upgrades of our software. And then you come to the free upgrade. As you scroll down from the maintenance page, you come to the free upgrade, and you can click that to bring you to the page, to the place where you need to enter your email that's been registered with us against your account to get your free upgrade. So again, thank you all very much for your attention, and we look forward to hearing from you, and happy unscrambling.